Okay, a power is a product of repeated factors. A power is a product of repeated factors. The example is in pink. Do you see how we are repeating the same multiplication over and over? 3 times 3 times 3 times 3 times 3. It is a repeated factor. It's the same number being multiplied over and over. So a power is what we call that when we're multiplying the same number by itself multiple times. Okay, product indicates that it's multiplication. The product is the answer to a multiplication problem. So just know that vocabulary. A product means we're doing multiplication. Okay, and then repeated factors means we're doing the same thing over and over. Okay. When we take something and to put it into exponent form, which is what we're going to be talking about today, we have different parts of the power. First, we have the base. The base is the number that's being multiplied by itself over and over again. So in this example, our base is 3, right? Because we're doing 3 times 3 times 3, like times itself over and over again. So our base is the repeated factor. In this case, in our example, the base is 3. Right? And the exponent, the last part of this, tells us how many times we are multiplying that base, in this case the 3, by itself. If we go back to our original, we did 3 times 3 times 3 times 3 times 3, right? 1, 2, 3, 4, 5 3s. So notice the exponent goes up and to the right of that base. So it's kind of smaller and up above. Do you guys see how it's written like that? The exponent tells us how many times we multiply this 3 by itself. How many times we multiply the 3 by itself? In this case, it was 5. Okay? So altogether, that little expression we say 3 to the 5th power is how we would say that. 3 to the 5th power. And we call it all together, the base and the exponent, we call it a power. Because it has a base and it has an exponent. All together we call it a power. Okay? Should we do some examples? Okay. All right. Here's our first example. It says, write as a power. A power has to have a base and an exponent. This, as it's written, is called repeated multiplication. And that's a fitting name, right? We're repeating, multiplying the same number. But instead of this, we're going to make it more simplified, more straightforward, and we're going to write this as a power. So go ahead, there are 5 7s there as you're writing, because sometimes it's hard to see. It's 7 times 7 times 7 times 7 times 7. So 5 times we multiplied that 7. Can you take this repeated multiplication and write it as a power? All right. With a hand, what would your base be? What is the number that's being repeated? Roger, what's your base? 7. Very good. And the exponent tells us how many times we repeated that base.
5.
Liam, what would your exponent be?
5.
5. So remember, we write the exponents a little smaller, and it goes to the right of that base. Bless you. How do we say this number? How do we say it in proper mathematical terms? Edna?
7 to the 5th power.
Perfect. 7 to the 5th power. Very good. Let's do another one. Letter B. 12 times 12 times 12. 12 times 12 times 12. In your notes, can you write this as a power? Okay, write it as a power. Take this repeated multiplication and write it as a power. Notice our base is the number that's being repeated, and our exponent should tell us how many times we repeated it. Dylan, what did you say?
12 to the 3rd power.
Perfect. 12 is our base to the 3rd power. So notice our exponent is little. It's up to the right, and we say that 12 to the 3rd power. Very good. Let's do one more. Letter C. 100 times 100 times 100 times 100. Go ahead and write that repeated multiplication for letter C. Write that as a power, please, in your notes. Notice your base, then notice how many times you're multiplying it by itself. Modibo, what'd you get?
I go 100 over the 4th power.
100 to the
For the 4th power.
4th power. Perfect. 100 to the 4th power is your power. Very good. Bless you. We left it as a power. In this case, it tells us to find the value. So in this case, we're going to actually have to do the math and find out what does that power equal if we do the math. So let's look at an example. 7 squared. Now it's important because now we need to remember that an exponent means repeated multiplication. It does not mean that you multiply the base by the exponent. That wouldn't get us the right answer. What does 7 squared actually mean? What are we going to actually do here? Will?
Multiply 7 by 2. No, I mean 7 by, like, 2 sevens.
7 by itself.
Yeah.
7 by itself 2 times, like this. Is that what you're trying to say?
Yeah, that's what I meant.
That's exactly right. We multiply 7, the base, by itself
49.
2 times. Right, which gives us what, Hudson?
49.
49. If you did 7 times 2, what would happen? 14, is that right?
No.
No. So be careful with your exponents. Make sure you remember it's repeated multiplication. Letter B, 5 to the 3rd power. 5 to the 3rd power. What does that really mean, Liam?
5 times 5 times 5.
Perfect. 5 times 5 times 5. Not 5 times 3. Be super careful you don't do that. This takes a little bit more math. It's not quite as easy as 7 times 7. So I'm going to give you a second to work this out. 5 times 5 times 5. What'd you get when you do 5 times 5 times 5? What'd you get? Colin?
125.
Very good, 125. If you did 5 times 3, what would you have gotten? 15. What do you notice about these exponents? What happens to these numbers as we evaluate? Mia? Colin, what do you notice?
It gets way bigger.
Very good. Very good. Notice how much bigger, right? 5 to the third gets really big really fast, right? Even though it's a small number, exponents get really big really fast because we're multiplying one number by itself over and over again. So exponents get really big really fast. Okay. I'm going to give you a couple to practice. Okay, you can just say try it. I think these are going to all come up. Okay, there are 3 for you to try. It says write as a power. So should you solve? No. Please leave it as an exponent. If it says write as a power, leave it as an exponent. So I'm going to give you, I don't know, a minute. Number 1. We have 2 times 2 times 2 as a power. Roger, what'd you say?
2 to the third power.
Perfect. 2 to the third power. That is correct. Number 2, we have 6 times 6 times 6 times 6 times 6 times 6. Tate, what'd you get?
6 to the power 6.
Very good. 6 to the 6th power. And finally, number 3, we had 15 times 15 times 15 times 15. Layla, what'd you get?
15 to the 4th power.
Perfect. 15 to the 4th power because we multiplied 15 by itself 4 times. Let's do a few more. What do you think these ones are going to have you do? Prediction time. Mia?
They're actually going to do the power.
Do the power. Find the value.
I think they're going to make us like.
Find the value. 6 to the 3rd, 9 to the 2nd, 3 to the 4th. Find the value. 6 to the 3rd really means what? 6 to the 3rd really means what? Colin?
216.
Oh, you're a step ahead of me. What does it really mean before we get to 216?
6 to the third power.
6 times what?
3.
No, not 6 times 3.
6 times 6 times 6.
Very good. 6 times 6 times 6. And yes, when we do the multiplication, 6 times 6 is 36. Times 6 is, Colin, what'd you say?
216.
Yeah. 216. Number 5, 9 to the 2nd or 9 squared is what? Kennedy?
81.
81 because it's really 9 times
9.
9. Not 9 times 2 because it's a power. Number 6, Miles, tell me what 3 to the 4th really means before you tell me the answer.
3 times 3 times 3 times.
Perfect.
Equals 81.
Good. 3 times 3, that's a dot, is 9 times 3 is 27. Times 3 is 81. All right? Okay, so remember, when we are taking a number to a power, we multiply that base by itself that many times. We don't do the base times the exponent. We do it times itself that many times. Hudson? Yes, you may. All right. You see how we got these, right? 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4, 5 times 5, 6 times 6, 7 times 7, and so on. These go on forever. I would highly recommend you memorize the perfect squares through your 12s. Well, maybe through your 15s. It'll be helpful.
With the age?
The perfect squares. All the perfect squares. So 49, 64, 81, 9 times 9. That's 12, yes. Good. We'll work on it. Yeah, 100. 10 times 10. 121. 144. 169 is 13. 14. 192. 225. Anyways, we'll get there. But just know that that's what a perfect square is. Okay. we don't need to write this, but what pattern do you see? To get a perfect square, you multiply a number by itself, right? All right, I'm going to